Okay, ready?
Yes.
Okay. The first thing I need to teach you is kind of the beginning of the first part of the lesson, but just kind of like a little commercial break at the beginning of the lesson. Okay? So we're going to start here. 3 to the x power equals 9. You know we're solving equations today, right? You're solving logarithmic equations today. And the first equation I give you doesn't have a logarithm in it. Are you okay with that?
Sure.
So, like, why am I calling this a logarithmic equation? Where is the variable?
Hiding.
It's hiding in the exponent, right? The variable is in the exponent. Guys, the only way we can get variables out of exponents is using logarithms. That's why we have to know how to do logarithms, okay? But why did I give you this specific example? Do you know?
It's probably easy.
Is it? What's x?
3.
3 to what power equals 9? 2, right? We already know the answer before we start. Okay? So I'm going to teach you the process, and then I'm teaching you just a little, little tiny lesson here at the very beginning. Okay? So when the variable, when the base is isolated, this base is isolated, isn't it? There's nothing being added, subtracted, multiplied, or divided to this base. When the base is isolated, we want to write it in logarithmic form. I want to write it in logarithmic form. What does this look like in logarithmic form? Well, we did that a couple days ago, right? Log base what? What's the base here? So it's the base here.
Log 3.
Base 3 of 9 equals x. Okay? Now, let me show you something real fast. Hold on. A long time ago, in a galaxy far away, or when I was in high school, when we did logarithms, let me find it.
Is that like some? Oh.
It's not.
Oh.
In order to do logarithms, we had to use these tables.
Nice. Whoa. I don't like it.
That's what we had to do in order to solve logarithms. Okay? Do you want me to teach you how to use these tables? Yeah, I don't want to have to. Right? I don't want to have to teach you how to use those tables. Okay? But then one day, somebody figured out how to use your calculator to solve logarithms.
Calculator.
And then they not only figured out log base 10, but they figured out natural log.
Is that much?
And then one day, someone figured out how to press, when you press log in your calculator, it automatically gives you, so I can solve any base in my calculator. Log base 3 of 9. Enter. Now, we already knew the answer was 2, right? We decided that ahead of time. The answer was 2, so yay, we got what we were supposed to get. Okay? But now, number 1, now you know a little bit of the steps that we have to do, right? We want to go from exponential to logarithmic form. But here's our mini lesson. Okay? Our mini lesson. First of all, let me write x equals 2. Okay? There was a time when we had calculators that just looked like this, right? Now, I know that there was teachers that told you you have to know how to do stuff by hand because you'll never always have a calculator with you. Well, they just didn't know, right? They didn't know that this kind of technology was going to be possible, okay? They especially didn't know that this kind of technology was going to be possible, did they? Look. Now, do you see a problem with this, though? Here's natural log, here's log base 10. Where's the other log bases? There's not one. Okay? So I want to show you something in this amount of space right here that used to be a whole entire lesson. Like a whole day. Okay? Because you can do this problem on this phone. So if you don't have your calculator with you, you can still do logarithms. If you're just super bored and you just want to do logarithms, you can. Yes. Yeah, get your phones out. Let's try it. Let's make sure you know what buttons to push. I did this the other day, and someone was like, "Wait, you can do that?" I'm like, and they said my phone doesn't do that, and I'm like, "Well, if it's an Apple, it does." And then they were surprised. That was nice. Okay. Here's what you have to do. Right? Look at the problem. Look at the problem right here. Log base 3 of 9. Here's what you have to do. Log of 9 divided by log of 3. Now, where do those two numbers come from? The big number and the base. Does it make sense that the base goes on the bottom of the fraction? Now, look what you have to press. Hold on, I have to open my phone. Look what you have to press in your phone calculator to make this work. You have to say 9 log divided by 3 log, and then press enter.
2.
Isn't that what we already decided the answer was?
Well, I didn't get that. What did you do again?
Okay, so
9
log
log
divided by 3 log
enter.
Oh, I got 2. I got
Okay.
negative 46 the first time.
Yeah, that's
Oh,
not
I
good.
got 2 now.
Okay.
Yes, that's
Everybody's okay?
yes.
So this is called the change of base formula. Change of base. And it's for when you don't have a calculator that can do any base like us. Like these calculators can do any base. This calculator cannot, but we can still do it if we know change of base formula. Does that make sense? Okay. All right, now let's start with problems that we cannot know the answer to right off the bat. What about this one? 3 raised to the x power equals 10. I know it's almost, like it's probably close to 2, right?
2 point something for sure.
2 point something for sure. I know it's going to be above 2 because 9 is less than 10. 10's greater than 9, so it's going to be more than 2. But I don't know exactly what it is.
2.23.
Okay? I mean, I know exactly what it is because I know how to do this problem, but you're about to, right? Is the base isolated? Is anything being added, subtracted, and multiplied to the base? No? Then I want to write it in logarithmic form. So, log base 3 of 10 equals x. Log base 3 of 10.
See, that's what I said, 2.23.
That doesn't say 2.23. Now, we need to decide right now together how many decimal places we're going to round to. What is almost always safe? 3, right? For logarithms, we're going to go to 4. Okay? For logarithms, we're going to go to 4. All right? So what is that technically? What is the mathematical term for 4 decimal places? Tenths, hundredths, thousandths, 10 thousandths. Okay? So 2.0955 2.0959 1, 2, 3, 4. I look to the next term to see if it rounds, and it doesn't, so that's just my answer, right? All right, 3 raised to the 2.0959. It should be 10.
It's pretty dang close.
It is pretty dang close, and is that okay?
Yep.
Why is it okay?
Because we rounded.
Because we rounded. Okay? Now watch this. If I go up here and say 3 raised to that number, isn't that the number that we rounded?
Yeah. We'll get 10.
You do. Okay? Any questions on that one? All right, what about this one? E to the x power plus 5, e to the x plus 5 power
It's not
equals 7. E to the x plus 5 power equals 7. Is the base
No.
isolated?
Wait.
The base.
The base
The
is.
base is. I'm not talking about what's in the exponent. I'm saying it's anything being added, subtracted, multiplied, or divided to the base. No. If it's isolated, then what? Logarithmic form. Okay, so here I wrote log base e because that was what the base was. Do I write log base e? I write ln. Very good. ln of 7. So ln stands for what again? Natural log. I know it's backwards. It's fine. Okay. Equals x plus 5. Now watch what I'm going to do here. Okay. I'm going to go ahead and hit minus 5, minus 5. Even though I don't know what natural log of 7 is yet. I know in order to solve for x, I'm going to subtract 5. Because now in my calculator, I can say natural log of...
2 equals
No. Still natural log of 7. But then I'm going to say out here minus 5.
Negative 3.
Negative 3.0541.
Can we get
Oh, I know. I don't know. Can we?
I don't know.
Like we did. What should we do to make sure that's okay?
Check it.
Check it. Okay. So E. No, I said E. Well, I didn't say E. I said that on accident. Negative 3.0541 plus 5. What should that equal?
7.
7?
Close, all that.
It does get pretty close, doesn't it? Is it close enough to say that it's right?
Yes.
Yes. Okay. Any questions?
No.
You okay so far?
I'm fine.
2 times 5 to the 2x power equals 8. Two times 5 to the 2x power equals 8. God bless you. Is the base isolated? No. Can I tell you that the most popular incorrect thing people do right here is say that that's 10?
Really?
Okay? Why can I not do that? Because there's an exponent. Because there's an exponent on 5, I can't mess with this at all until I can get the variable out of the exponent. But I do that by taking logarithms. So what do I do with this 2?
Bring it to
I
the
do.
front.
I divide it.
Oh.
I divide both sides by 2. When I divide both sides by 2, what happens to these 2's? They simplify to 1, right? And I just have 5 to the 2x power equals 4. Is this base isolated now? Was it isolated up here? No, it was not. So I couldn't write it in logarithmic form until it's isolated. Now that it's isolated, I want to write it in logarithmic form. So log base 5 of 4 equals 2x. Now once again, before I even put this into the calculator at all, I'm going to go ahead and divide both sides by 2. Now I don't have to do that now. I can wait, right? I can go ahead and put log base 5 of 4 in the calculator and get an answer, and then I can divide it by 2. But I want to go ahead and do that because I know what to do next. It's telling me what to do next, right? So log base 5 of 4 divided by 2. Now, because you know how cool our calculators are, please understand I could do this all in one step. I could make a fraction that says log base 5 of 4 divided by 2, and it is exactly the same. Do you see that? Do I care which way you do it? No, I do not. Okay? 0.4307, right? Now, here's what can happen. If I don't want to round too early. Okay? Here there's only one step after I have to round to get to the answer, but in some problems there's 2 steps before I get to the answer. And if I round too early, I risk getting this number right here or these 2 numbers incorrect if I round too early. So please do not round too early. Okay? Any questions? We good so far? God bless you. Now what about this then? E raised to the x plus 4 minus 5 equals 7. Is the base isolated? No? Okay, what do I do first then? Add 5. E raised to the x plus 4 equals 12. 7 plus 5. Is the base isolated? Yes. Why do some people not think the base is isolated? Because of the plus 4, but we know, God bless you, we know that that's in the exponent, right? And we know that that's fine. Now that the base is isolated, what do? Logarithmic form. What is logarithmic form here? Oh yeah, ln, because we've got an e going on into our base, right? So natural log of 12 equals x plus 4. What do you want to do right now? Okay, so we can do that. Natural log of 12. Am I going to go ahead and round this? No, right? We're not going to round it. We don't want to round too early. So how am I going to solve for x? Subtract 4, right? So just subtract 4 from that number right there in your calculator. And I get x equals negative 1.5151. Yes? Is it correct? Do it. Check. Check it. Is that 12? No, but yes, right? We rounded, so we expect a slight error like that when we round. Yes?
What should the time of these notes be?
Solving.
Just solve?
Solving logarithms. All right, you ready? What if the problem looks like this? So in the last problems that we did, it didn't say log at all. And we had to go from logarithmic, or from exponential form to logarithmic form, right? What if it shows up like this? What do people usually do right now? Panic and freak out, right? Except, guys, if it says log on both sides of the equation, if the log of this has to equal the log of this, don't these two things just have to equal each other? So is there any rewriting that's necessary in this problem at all? Or can I just say x plus 5 equals 2x minus 9? Do you see what I'm saying? People have a tendency to panic when it says log on both sides. There's no reason. If that's all that's there, log of something with log of something, those two somethings just have to equal each other. And you've been doing these equations since 8th grade? 9th grade? Maybe some of you were super advanced in 7th grade? I don't know. Right? So I just need to subtract x from both sides and add 9 to both sides. So what does x equal? 14. Now, I haven't shown you this way to check so far because so far it wouldn't have worked. And you'll see why in a second. Okay? But I want to remind you that you can do log of 14, what does it say, plus 5 equals log of 2 times 14 minus 9. True. I just put it straight in the problem exactly as it is, except I substituted 14 for x, and it says true. What does that mean about this answer? It's correct, right? It's true. All right? So why haven't I shown it to you before now? Okay, why wouldn't it have worked? Because we rounded, right? And does this equal 12? No, it does not, and this would have said false. And you would have been worried that you got the wrong answer. Okay? So if there's any sort of rounding that went on, this is not going to work. Does that make sense? Okay? But that's there to check in case you need it. Okay? All right. Now, what happens if there's only one log, though? That's what we need to get to. Negative 3 log base 5 of x equals 12. So just like on the previous problems where we said, is the base isolated before we could go on, in these problems, what do I have to get isolated? The log. Is this log isolated? No, it's not. Okay, I'll say what you said. That's fine. Heck no, right? This log is not isolated. What do I have to do to isolate the log? I have to do something with the 3, right? The negative 3 is what's the problem. I don't want you to think the 5 is the problem. I don't want you to think the x is the problem, because that's all part of the log, right? So what do I have to do with the negative 3? I know that's what you want to do. I want to get rid of it from that side of the equation. Why do I want to divide it and not add it? It's multiplying to the log, right? So I want to divide both sides by negative 3. Does that make sense? So negative 3 divided by negative 3, that leaves us with 1 on that side. So on the left-hand side, I just have log base 5 of x. And what does that equal? Negative 4. Now, is the log isolated? Once the log is isolated, where do I want to go now? Last time, when it was in exponential form, I took it to logarithmic form. Now that it's in logarithmic form, where do I want to take it? Exponential form. So what's the base of this exponent? Or excuse me, let me use my correct vocabulary so you can actually answer my question. What's the base of this logarithm? 5, then it needs to be the base of my exponent. To what power? Negative 4 equals my argument, which in this case is x. Now, if you don't know 5 to the negative 4th on the top of your head, we just go 5 to the negative 4th in our calculator. And it tells us x equals 1 over 625. Any questions about that? Now, is that easy to check? Is this one we could check with the equal sign? Let's see. Log base 5 of 1 over 625. Now, right now I could press equal and just see if it equals negative 4, right? But I'm just reminding you that you can do it this way. Does it work? Yeah. But if I just had this part, remember I could press enter, negative 4. We know we can look at our paper and see that's negative 4. We know that's right as well. Yes? Okay. Log of x minus log of 3 equals 2. Can I fix this real quick? Sorry. Plus. Log of x plus log of 3 equals 2. So it says log 2 times, so I just set these two equal to each other? No, not this time, right? Not like we did before. Before we could do that because the logs were on either side of the equal sign.
Can't you do x plus 3 equals 2 though?
I want to do something about that, right? Isn't this very similar to what we did yesterday? Right? So when I'm adding two logs together and I want to write the log one time, what do I do with the two things that are here? Multiply them. So log of 3x equals 2. is the log isolated? Yes, because this 3x is inside the log, right? Okay, now I'm going to have to deal with that 3 in a minute, but not right now, right? If the log is isolated, where do I go? Exponential form. What's the base of this log? There's not one written. It's a good guess. It's 10. Do you remember that? So 10 to what power?
2,
Equals
3x.
3x. What's 10 to the second power? 10 times 10? 100. So 100 equals 3x. So divide both sides by 3. So what does x equal? Don't make it too difficult. 100 over 3. Any questions about that? Okay, let's try another one then. Log of 2x plus 5 minus, oh, can I fix it? Can I fix it? It's just supposed to be ln. Sorry about that. ln of x equals 7. So natural log of 2x plus 5 minus natural log of x equals 7. This is very similar to the one we did right before it, right? But what does that mean? Divide, okay? So natural log of 2x plus 5 over x equals 7. Is my natural log isolated? Yes, because remember this is all inside the natural log, right? Okay, so if the natural log is isolated, where do I want to go now? Exponential form. What's the base of this log? Not this time. E, right? So e to the 7th power equals 2x plus 5 over x. How do I get rid of that x? Both sides by x, right? I need to multiply both sides by x. X here and an x here, because that simplifies to 1. Now I have e to the 7th x equals 2x plus 5. Now please do not panic on me here. I know that there are 2 letters here, but is this a letter? It is not a letter, is it? It is the number e that we can get a value for my calculator by saying e to the 7th. Okay, now it's going to get kind of messy here for a second. Okay, so we're not going to let our paper get messy. We're going to let our calculator do the messy stuff for us, okay? What I need to do is subtract 2x from both sides, right? Well, if I subtract 2x from both sides, that gives me 0. So on this side I just have 5. And on this side I have this number x minus 2x. So I need a minus 2 from that number. So now I'm going to go ahead and 1094.6331, but I'm still not done because I still have to divide both sides by that number, right? Divide both sides by that number, 1094.6331 something. Not rounding all the way. So 5 divided by, I'm going to use my calculator's answer property because I don't want to have to type that whole number in. So I said 5 divided by and then control and then negative sign. See where it says answer? Now it says A and S on the screen. It's going to pull that number down into the problem without me having to retype it. So x equals 0.0046. Now I haven't checked all of these, have I? Are you going to check all of them? Probably a good idea. I haven't checked all of them, but is this one maybe a good idea for us to check? Because that seems a little out there as an answer, right? Okay, so let's see, natural log of 2 times 0.0046 plus 5 minus natural log of 0.0046. Is it right? Yeah. Is that close enough to 7? It is. Especially since we had to substitute it in 2 different times, right? Okay. Keep in mind that here, this one was pretty easy. I just multiplied those two. But what if this was a plus sign? What would have I had to do with these two things? Multiplied, and it would have given me an x squared, and I would have had to factor, right? Keep in mind, you're probably going to have to factor at least once on your homework. You'll have an x squared term. You'll get 2 answers, right? Okay. Are there any questions?